Good morning, students. In second lesson, P blocks 1, P block elements 1. Today we are going to learn about boric acid. The formula of the boric acid is H3BO3. H3BO3. This is the formula of boric acid. First one, preparations of boric acid. Na2B4O7 is reacted with sulfuric acids H2SO4 with water. It gives boric acid and sodium sulfate. This 2 sodium takes this SO4 means it forms Na2SO4. Remaining all are combined means you will get 4 molecules of boric acid is obtained. In second reaction, that is colemanite, that is also reacted with water and sulfur dioxide. It forms calcium bisulfate with boric acid. So, boric acids can be extracted from borax and colemanite. This is the preparation of boric acid. Next one, properties. Boric acid is a colorless transparent crystal. It is very weak monobasic acids and it accepts hydroxyl ion. It accepts hydroxyl ion rather than donating proton. It accepts hydroxyl ion. So, boric acid formula is H3BO3. It can be written BOH thrice. It absorbs water molecule. It absorbs OH minus ion from water molecule. Means it forms BOH4 minus. After losing OH minus, H plus ion only present. So, that water takes that H plus ion means it forms H3O plus. So, here boric acid takes OH minus ions, accept OH minus ion. It reacts with sodium hydroxide. To form sodium metaborate, that is NaBO2, and sodium tetraborate, that is Na2B4O7. So, boric acid is reacted with sodium hydroxide to form sodium metaborate and sodium tetraborate. 2 reactions are possible. What happens when boric acid react with NaOH? For that question, you have to write these 2 equations. Next one, action of heat. Boric acid, when heated at 373 Kelvin, it gives metaboric acid, and 413 Kelvin it gives tetraboric acid, and when heated at red hot it gives boric anhydride, which is glassy mass. See these reactions, students. Boric acid at 373 Kelvin it gives metaboric acids. Metaboric acid. At 430 Kelvin it forms tetraboric acids. Tetraboric acid. And red hot it forms boric anhydride. Boric anhydride, which is having glassy mass. So, 3 different products are obtained. Explain the action of heat on boric acid means you have to write all these 3 equations. First, it forms metaboric acid, after that it forms tetraboric acid, after that it forms boric anhydride. Next one, action of ammonia. Ammonia means NH3. Boric acid react with ammonia. This 3 hydrogen takes this 3 OH means 3 water molecule is removed, remaining boron and nitrogen both are combined means you will get boron nitride. So, fusions of urea with boric acid in an atmosphere of ammonia at 800 to 1200 Kelvin, it gives boron nitride. That is, boric acid react with ammonia means it gives boron nitride. When next one, ethylborate test. When boric acid or borate salt is heated with ethyl alcohol in presence of concentrated sulfuric acid and ester, that is triethyl borate. Triethyl borate is formed. The vapor of this ester burns with green edged flame, and this reaction is used to identify the presence of borate. How will you identify borate radical means you have to write these 3 lines with this equation. See this equation, we can write that boric acid H3BO3 as boron with 3 OH group. This is H3BO3, that is boric acid. It is reacted with ethyl alcohol. How many molecules? 3 molecules of ethyl alcohol, C2H5OH, C2H5OH and C2H5OH. This boron takes this group means 3OC2H5 group means it forms BOC2H5 thrice, that is triethyl borate. Remaining these 3 hydrogen takes this 3 OH means 3 water molecule is obtained. So, boric acid is reacted with ethyl alcohol means it forms triethyl borate is obtained. This reaction is used to identify the presence of borate. Very important question. Note the trialkyl borate on reaction with sodium hydride in tetrahydrofuran to form a coordination compound, that is NaBHO or thrice, which act as a powerful reducing agent. So, in our previous reaction we got trialkyl borate, triethyl borate. That compound reaction with sodium hydride means it forms one coordination compound. This compound acts as a very powerful reducing agent. This is one of the additional point. Next one, formations of boron trifluoride. Formations of boron trifluoride. Boric acid react with calcium fluoride CaF2 in presence of concentrated sulfuric acid and gives boron trifluoride. This 3 calcium takes this 3 sulfate and forms 3 calcium sulfate. Remaining this boron combined with the fluorine means it forms boron trifluoride. Remaining hydrogens, 6 hydrogen takes 6 OH, 6 hydrogen takes 6 OH means it forms 6 molecules of water. And boric acid when heated with soda ash, this is boric acid, boric acid is heated with soda ash, that is sodium carbonate, means it gives borax, which is having formula Na2B4O7. Na2B4O7. From this CO3, CO2 is removed, and from this boric acid 6 water molecules removed, remaining ions are combined, means we will get borax, formula Na2B4O7, formations of boron trifluoride. So, in first reaction BF3 is obtained. In second reaction, that boric acid is react with soda ash, means borax is obtained, that is Na2B4O7. Next one, structure of boric acid. Boric acid has a 2-dimensional layer structure. It consists of BO3 3 minus. BO3 3 minus. Actually, this is the structure, BO3 3 minus unit, and these are linked to each other by hydrogen bond. This dotted line indicates hydrogen bond, because already you know hydrogen bond means that is the attractive forces present between the hydrogen and high electronegative element like fluorine or oxygen or nitrogen. Here that attractive forces is present between hydrogen and the high electronegative element oxygen. So, boric acid, it consists BO3 3 minus unit. This unit is linked by hydrogen bond. This is the structure of boric acid, and uses of boric acid is also given. Boric acid is used in the manufacture of pottery glasses, enamels and pigments. So, it is used in the manufacture industry for manufacture of pottery glasses, enamels and pigments, and it is used as an antiseptic, and also it is used as an eye lotion, and it is also used as a food preservative. Totally 3 uses are given in uses of boric acid. So, with this topic, boric acid topic over. With this uses of boric acid topic over. Topic, alums. The name alum is given to the double salt of potassium aluminum sulfate, that is K2SO4 Al2SO4 thrice 24H2O. The name alum is given to the double salt. The name itself contains the reason. Double salt means 2 salt, potassium sulfate and ammonium sulfate, potassium sulfate and aluminum sulfate. The formula of potassium sulfate is K2SO4, aluminum sulfate is Al2SO4 thrice dot 24H2O. Nowadays, it is used for all the double salts with M2SO4 and M2SO4 thrice. This is the general formula for alums. Here that M dash is univalent metal ion or ammonium, and M double dash is trivalent metal ion. Examples: for potash alum, K2SO4 Al2SO4 thrice 24H2O. Sodium alum, Na2SO4 Al2SO4 thrice 24H2O. Ammonium alum, NH4 twice SO4 Al2SO4 thrice 24H2O. Chrome alum, that is K2SO4 instead of Al2SO4 thrice, here Cr2SO4 thrice is given with as usual 24H2O molecules. These are some examples for alums. Alum is general or more soluble. Alums in general are more soluble in hot water rather than cold water, and in solutions they exhibit the properties of constituent ion. So, these are the general properties. Generally more soluble in hot water rather than cold water, and the solution exhibit the property of constituent ions only. Next one, preparations of alum. The alunite or alum stone is naturally occurring form and it is K2SO4 Al2SO4 thrice 4AlOH thrice. So, this is alum or alunite formula. When alum stone is treated with excess sulfuric acid, aluminum hydroxide, this aluminum hydroxide is converted into aluminum sulfate. A calculated quantity of potassium sulfate is added and the solution is crystallized. The calculated amount of potassium sulfate is added means to the solution, that aluminum sulfate combined with this and forms alum, that is K2SO4 Al2SO4 thrice dot 24 H2O. This is the preparations of alum. First, alum is prepared from alunite. Alunite formula is K2SO4 Al2SO4 thrice 4AlOH thrice. It is reacted with the sulfuric acid, means this aluminum hydroxide is converted into aluminum sulfate. So, that to that solution calculated amount of potassium sulfate is added means it forms alum, K2SO4 Al2SO4 thrice dot 24 H2O. So, this is the preparations of alum. Next one, properties. Potassium alum is a white color crystalline solid and it is soluble in water and insoluble in alcohol. This aqueous solution is acidic due to the hydrolysis of aluminum sulfate, and it melts at 365 Kelvin on heating, and at 475 Kelvin it loses water of hydrations and swells up. That swollen mass is known as burnt alum. So, heating to the red hot, it decomposes into the potassium sulfate, alumina and sulfur trioxide. See this reaction, this is alum, that is K2SO4 Al2SO4 thrice 24 H2O. On heating it loses water molecule. So, remaining K2SO4 Al2SO4 thrice only present. Again, if you are heating on red hot temperature, mean that K2SO4 is splitted here, and from this Al2SO4 thrice SO3 is removed, means you will get remaining Al2O3. So, that only given here. So, the swollen mass is known as burnt alum. After heating it loses water molecules. After heating it loses water molecule. After losing water molecule, the remaining mass is called as, that is the swollen mass is known as burnt alum. This is known as burnt alum. Heating to red hot temperature it decomposes means splitting. It is splitted into potassium sulfate and aluminum sulfate, aluminum oxide and sulfur trioxide. Is decomposed into potassium sulfate, alumina, that is aluminum oxide and sulfur trioxide. Potassium alum forms aluminum hydroxide. Potassium alum forms aluminum hydroxide when treated with ammonium hydroxide. Potassium alum, that is K2SO4 Al2SO4 thrice dot 24 H2O. Potassium alum forms aluminum hydroxide when treated with ammonium hydroxide. So, what happens when potassium alum is treated with ammonium hydroxide means you have to write this equation. See this equation, this K2SO4 it forms here, and this 24H2O is also formed as a separate product. Remaining 6 ammonium take this sulfate and forms ammonium sulfate. Remaining aluminum takes hydroxide group, means it forms aluminum hydroxide. Next topic, uses of aluminum. It is used for the purifications of water. Alum is used for the purifications of water. It is also used for waterproofing textiles, waterproofing and textiles, and it is used in dyeing, paper and leather tanning industry, and it is employed in styptic agent to arrest bleeding. To arrest bleeding it is used, and leather tanning industry, dyeing industry, paper industry it is used. In waterproofing and textiles also it is used, and in purification of water also alum is used. These are the uses of alum. Remaining we will continue in our next video. Thank you.